Good morning, Year 10. This is lesson number 2 of electricity. So today we are looking at current and charge. So why is electricity so important? What would you miss if you didn't have it? Try and think of something apart from your phone. Make a list. So who are these two people? Obviously, we're talking about electricity, so you've probably guessed they are something to do with electricity. So we have Benjamin Franklin and we have Thomas Edison. Who were they and why were they important? So Benjamin Franklin actually helped us understand, in modern terms, what electricity was. And his thoughts, I suppose a bit like Isaac Newton and the apple dropping from the tree with gravity, his thoughts were sort of instigated by apparently when lightning struck his kite that was flying in the sky. So he developed this theory and the principles of electricity. Thomas Edison is most famously recognised for inventing the light bulb. So what is electricity? It is actually a form of energy. We've been looking at energy for the last 3 topics, and it's actually to do with the flow of electrons. So it's the flow of electrons through a substance that causes the electric charge. So this flow of electricity or electric charge, so our tiny little electrons with our negative charge, as they flow along, they will form a current, a bit like the currents in a river. These currents are measured in amps. Their actual full name is amperes, but obviously we say amps, which you'll probably have heard of with certain gadgets in your house or a plug in your house that might be a 6 amp or a 13 amp. So the flow of electric charge is called a current, and current is measured in amps. And as you know, in our electric devices and our plugs, it is flowing through a wire. So let's flash back to years 7 and 8. What's a circuit? So a circuit, we must remember circuits are basically an electrical device that allow electricity to flow through them. So actually they are a device to allow electrons to flow around them. And when we get a complete circuit, electricity will flow all the way around. So if we look at these 2 diagrams here, there's a slight difference. So one has got a switch that is open and one has got a switch that is closed. So you can see in diagram B, the switch is closed and the bulb is glowing yellow, which means there is a complete circuit. In diagram A, however, the bulb is off and the switch is open. The bulb cannot work unless there is a complete circuit to allow that electricity, that current, that flow of electrons to get all the way around the circuit. If there are any gaps in it whatsoever, the circuit will not work properly. So flashback again. We are going to look at all these symbols here. You need to know these off by heart and you need to be able to put them into your own circuit. So I want you to copy these symbols, label them, learn them, and then draw a circuit that contains a cell, a bulb, an ammeter, a resistor, and a switch. So now you need to pause the video and do those 3 separate tasks. So you have just drawn a diode and a resistor. So what are they? They are actually opposites. So a diode is something that allows current to flow easily through it in one direction. A resistor, on the other hand, resists electricity by reducing the current that flows through it. You can get, as in the diagram you did before, a variable resistor where you can actually adjust how much current is going through it. On the screen, you've actually got a picture of a resistor, and you can get different kinds of these, and these are basically placed into a circuit or into an electrical device, and this will basically control the amount of current, the resistance to the current that allows it to flow through a particular circuit. Hopefully, once we're in school, we will be able to make some circuits and you'll be able to see a resistor in real life. As always with physics, we need a little equation here. So here we have the equation that basically connects charge, current, and time. So you have a maths triangle on the screen. What I want you to do is work out what the equation is for Q, and then rearrange it to work out the equations for I. I means current and T means time. Please note that charge is measured in coulombs, and that's a capital C. Current, we already know that's measured in amps, that's a capital A. And time, we also know that is seconds, which is an S. So actually, the only new piece of information here is that our charge flow is measured in coulombs. So the size of an electric current is the rate of flow charge. So write down the maths triangle, work out what Q, I and T are, and write down the statement in blue. So from that triangle, you should have worked out that Q equals I times T. So the charge is current times by time. Then you should have also been able to work that if you were trying to work out what the current is, so what I is, it would be the charge Q divided by T. And then if you're trying to work out the time, which is T, you need to do the charge, the Q, divided by current, which is the I. So we have a little question here. So a hairdryer transfers 48 kilojoules of energy in 1 minute. What is the power rating of the hairdryer? So use your equation from the last slide and work out what the power rating is of the hairdryer. So I want you to read this box here and then think about what words could actually go into the box. So if a cell is added, the current will what? Because there is a greater blank on the electrons. And then the second box says if a bulb is added, the current will, what do you think it's going to do? Because there is greater blank in the circuit. So pause the video. And then I want you to have a go at what the missing words are, and then obviously move ahead to find the answers. Okay, so last task of the lesson, I would like you to copy down these 5 bullet points and then use the words at the bottom to fill in the missing words. The answers are on the next sheet to follow. Hi everyone, well that brings us to the end of our lesson on current and charge. Well done for participating. See you tomorrow. Don't forget to check your emails and scheduling.